Hi everybody, this is Mr. Karlovsky again, and we're going to work on section 9.4. You should have watched a video about how to add up the whole numbers from 1 to 100, and it's a clever little story and a cute story, but I want to kind of generalize the pattern for all sorts of other sequences, right? So just as a reminder, if we have 1, 2, 3, all the way until, let's say, we get to the middle of 50 and 51, and then we go to the end and finish with 98, 99, and 100. Well, we saw the pattern by Gauss, is the story, that all he did was he paired up the numbers and he realized that that made 101 and that made 101, and that every pair, as you work outside in or inside out, added up to the same constant. And so he realized that, hey, I've got 50 pairs of 101, and so that would just be 50 times 101, which isn't that hard to do in your head, 5,050. All right, so that was the story, and it's a cute little story about Gauss when he was a kid and all that. But now let's generalize it for other sequences. Because the connection to what we did in section 9.3 is that although we think of the numbers 1, 2, 3, 4, 5 as just the whole numbers, the counting numbers, those really that really is an arithmetic sequence, right? It's a very boring arithmetic sequence with a d value of 1. Just 1, 2, 3, right? It's plus 1, plus 1, plus 1. So what we just found, that example, is something called an arithmetic. And now, instead of the word sequence, we're going to use the word series. And I know those words kind of sound the same, and every once in a while I screw them up. But basically, an arithmetic series, it's all about the addition, is that a series is the sum of terms of a sequence. All right, so now we're going to talk about an arithmetic series, means the sum of terms of an arithmetic sequence. So let's kind of look at Gauss's pattern just with more generalized terminology. So we know that the first term of any arithmetic would be a sub 1. Then the next term, instead of writing a sub 2, I'm going to write a sub 1 plus d. And then the next term would be a sub 1 plus 2 d's. Now, I don't know how long this sequence is, but I know eventually it ends, right? I'm not going to add up an infinite number of numbers, at least not right now. We're going to add up a set number of numbers. Now, instead of me writing a sub 1, now what if I went backwards? Because that's kind of the beauty of the pattern. So I'm going to leave a little bit of spacing here. So what if I said, hey, we're going to go all the way to the last term, a sub n? Okay, well then what that means is if this is the arithmetic sequence, then the term right before a sub n would be a sub n minus d, right? Think of it as just backing up the d value, and then a sub n minus 2d. And so that's really the beauty of the pattern that worked for Gauss and is going to work for us, is that when you think of it as this arithmetic sequence, every time I move from left to right or inwards, I'm adding d, and every time I move right to left, also inwards from the other side, I'm subtracting d. And so now if you think about it and look at it, well, now what do the sums of these pairs add up to? Well, if I do a sub 1 plus 2d plus a sub n minus 2d, well, the 2d's would cancel, and I just get a sub 1 plus a sub n. And then same thing for this pair, is that I'd have a plus d on one, minus d on the other. That adds up to a sub 1 plus a sub n. And of course, if I go to the very beginning, the very first and the very last, that is a sub 1 plus a sub n. All right, so now we've made pairs. So if I've made pairs, then how many pairs are there? Well, if there are n terms in the sequence, then there are n over 2 pairs. And then how much is each value, or each pair in this case? A sub 1 plus a sub n. So therefore we come up with a really simple formula that is n over 2 times a sub 1 plus a sub n. All right, and so the notation we're going to use for this, since it's a sum, we're going to use a capital S with the subscript of n. So that's the way to say, hey, what's the sum of the first n terms of an arithmetic sequence? And again, this is the formula. This only works for arithmetic series. And that's really the first part of today, is to learn this formula. I know we have a lot of formulas for this chapter, but luckily you have your notes with you for any problems that we're doing. All right, so let's do an example of this formula. Okay, now the problem I like to do first is it looks really simple. I say, hey guys, 11 plus 17 plus 23. And I say, hey, let's just continue that sum all the way. So the dot, dot, dot tells me, hey, continue. And we're going to end on 149. All right. Every once in a while, a kid will look at this problem and they're like, well, what am I supposed to do? And I go, well, those are plus signs, right? Those aren't commas. Those are plus signs. It's asking you to add up this expression, 11 plus 17 plus 23, all the way to 149. Well, if I want to jump to my formula says that the sum of these terms is n over 2. Okay, well, over 2. And I need the first term, a sub 1 is 11, and the last term of 149. So I got the first and the last, but at the moment, oh no, I don't know how many terms this is. So I like to call this a problem in a problem, because that sounds silly, is that we need to figure out how many terms is this, which means, hey, 149, where did you come from? And that's the connection to last section, is that we're going to think about the arithmetic sequence, right? Which I'll write again, a sub n equals a sub 1 plus d n minus 1. Hey, 149, where did you come from? Well, we have to do a little side problem, that 149 came from the first term of 11 plus, and the d value, 11, 17, 23, is clearly 6 n minus 1 times. All right, so this is the connection between the previous two lessons, is that we're going to solve this, and I'm just kind of doing my own way here, and I get 23 equals n minus 1. So I have to do this little side problem to figure out that there are 24 terms in this list to be added up, because the dot, 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 we didn't know. And so now I'm going to finish the problem by just bringing that 24 back into the blanks, 24. And now I'm just going to go to my calculator. Don't need to show any work on this. Go to my calculator, 24 over 2 times 11 plus 149. And the sum of those 24 terms is 1,920. Okay, basically think about all these problems as just having a lot of variables. And so either, we got to give you some variables and you're going to find the others. And we're not going to ask you to find something that you can't do. So just always have the confidence that one of the formulas we use has the ability to find the missing values. All right. We're going to finish this with an example I always like to do, I think kind of real world example of salaries and money. All right. Someday you will have a job, and sometimes we're going to have a pattern of our salaries. Okay. I'm going to do this in the first person. That back in 2003, my salary in my first year of teaching, so I'm going to say in year 1 of teaching, was $42,000. And that's pretty much true. All right, that was back in 2003. All right, well, let's pretend. Now, this part is not true, but let's pretend that every year I get a $4,000 raise. All right, so again, that part is not true. All right, so what are the questions that we can answer? Question 1. How much does Mr. K make in year 17? This is my 17th year of teaching. So how much would I make in year 17 with this pattern. All right, so now let's get to the math of it. Clearly, this is an arithmetic, right? Because I'm getting a set number of $4,000 every year. All right, so this is just a sequence problem, right? I want to know how much I make in a single year, 17. So we would say A sub 17, well, comes from my first salary of $42,000 plus my D value of 4,000. And then if this is year 17, I've had that raise 16 times, right? Because it's 17 minus 1. And so, all right, Mr. K, year 17, I would have $106,000, which may or may not be true. All right. Question number 2 is how much total has Mr. K made so far in my career? All right, so that word total kind of is the giveaway that this is about addition. So I want the sum of those 17 salaries, right? So from the very first year to now, year 17, what's the sum of all that money? Well, the formula says that it's 17 over 2. And we already know the first year was 42,000. And then luckily we already did part 1, which is how much am I making this year? 106,000. All right, and so even if I hadn't done part 1, we would have had to do part 1 because we would have needed this blank for year 17. And now I just go to my calculator and I get that I have made $1,258,000 in my career, rolling in it. That's the sum of my 17 years. Okay, and so you can see the difference between a sequence and a series. So now just for fun, go one step further. How much will I make in my career? So how much over my entire career of hoping to be around about 37 years total, not from now, but 37 years total from when I started. All right, so there we go. So now we're going to find what is S sub 37. And again, there's a nice little formula, right? It's N over 2. My first year was 42,000. And then now this is that example where, oh no, we have to find my 37th. So you can just, again, do it as a little side problem of, oh yeah, what would be the 37th year? Well, that would have been 42,000. So again, this is A sub 37. 42,000 plus 4,000, only 36 times. And I would just do that little calculation, and I believe you get for 186,000. Okay, so again, you just kind of do that as a little side calculation, and then you're done. You can see there's just a lot of plug and chug, and so the sum of 37 years of work is going to be $4,218,000, right? So when I was a kid right out of college, if they had said, hey, sign this contract for 37 years, $4.2 million, right? That's pretty crazy to think about that. But, that's kind of how we sometimes think about it for athletes and stuff like that. Signed a contract, 37 years, $4.2 million. Anyway, like I said, this is not true how teacher salaries work, at least not at the Glenbrooks. But just wanted to do that as a quick example of how arithmetic sequences and arithmetic series are related. Okay, so hopefully that new formula isn't too scary for you. It's just based off of that Gauss pattern of the number of terms divided by 2, and then you just have to add the first term plus the last term. And of course, there'll be other quirks that we'll do in other examples, but for a good start, that should be enough. All right, take care, have a good day, and we'll move on to the next part pretty soon. Take care.